That's typical. Sometimes you see 16, 17. But pretty much you want a minimum of 15 dB there. If you don't have that, you got an antenna problem, which you won't resolve. Just let us know about that. But the thing is, what we're after here is you're moving through, you're going to see this one first, and this one, and then this one, and there's probably, there's about 6 or 7 on either side. So what I'm getting at is that 25 C over N, when you get to the side lobe, okay, this one here is just going to barely be in there. This one here you may not even see. See, the bigger this guy is, the more the side lobes you're going to see is what I'm getting at. And the more these side lobes you see, the easier it is to find it. Because if you're moving too quick, and let's say that you don't see any of these, you just, like on a beacon, you're not going to see near as many of these side lobes. Like I say, you got a whole bunch of these out here. And on the beacon, you're not going to see near as many of them. So let's exaggerate it and say that you didn't see anything but the main lobe. If you're swinging through there and you happen to be looking the other way, zip, you go right by that dude and you've missed the bird. And then you do something stupid trying to find it and throw it way off and get on a wrong bird or something. I don't mean you, I mean we've all done it. So the higher that carrier, you're going to see more side lobes. So as you're swinging, you're going to start seeing some of these, and when you start seeing them, then you need to slow down. But I don't want to get into that anymore because we got a whole procedure that's written on how to transition.
To answer your question, polarization is different.
There you go. Thank you. The original question is, what's the difference between ASC1 and ASC2? And a minor point was that the beacons are different slightly, and you need to know that. That's good information to have down for the future reference. But as Mark said, the main thing here is that they're on different polarizations. Transponder 13, you notice this, the arrow pointing up is vertical. So in other words, if you're on transponder 13, you're uplinking vertical. But then the satellite not only translates that 2225 megahertz and sends it back down at the 4 gigahertz range, but also changes the polarization on you. So you're actually downlinking on horizontal, whereas if you're on transponder 13 and you go to SpaceNav 4, now you're uplinking on horizontal and downlinking on vertical. So where you were receiving on horizontal, which by the way, in our region, almost all of our Earth stations are on horizontal receive on ASC1, all but 1 or 2 exceptions. And none of you are exceptions, just Florida 35 and Tennessee 8. As far as I know, are the only 2 exceptions we have.
So we'll end up having to change the polarization.
Absolutely. Absolutely. So that's good, Mark. Big thing here is we're going to have to change our polarization. And what we'll probably do is we'll have somebody putting up a carrier on the horizontal so you don't have to change your polarization. You go ahead and swing through, find the bird, peek it, make sure you're not on a side lobe, and then we'll have you do your polarization. Again, that'll all be in that procedure. And before we get off of frequencies, let's talk about something else here. Like the center frequency here is 39. I don't have my bifocals on. What the heck is that, 3920?
Yeah.
My bifocal's broken, so they're in for repair, and I won't get them for a week or 2. 39, what'd you say it is?
That one's 30.
3920. Let me write that down so I can see it. And 13 is 3980. I'm going to zoom in on that, Kathy. Let's see. You got to bear in mind we're talking to people who are looking at this on camera. Have you been zooming at all? Okay. Tighter. Is that as tight as you can get? Zoom it in as far as you can. They can't see that very well, but they're going to have the same worksheets that you do. Let's get this in up here then so they can see where I write. What I want to get out here is that these larger transponders actually have more than one center frequency. They have what's called a low, mid, and high. Before I get into that, let's break it down and go back to the standard 40 megahertz wide. Let me get rid of this. We don't need that anymore. Okay, this would be the noise pedestal of a 40 meg wide transponder. And then, of course, on that, you know, you're going to have 50, 100, 150 carriers on there of different bandwidths. Now, this center on this one, which we'll just call that number 6, and it's 3920 megahertz. Now, what is the IF range of our equipment, our modems? Plus or minus 18. To put that another way, that's what? 52 to 88 megahertz. These two statements are saying the same thing. Now, as Steve's already hinting at, you know, plus or minus 18, it should be 20, but we got 2 megahertz each side for guard band on the transponders. Between these transponders, they got some guard band in there. Now, so we can shift our modems plus or minus 18 megahertz, you know, to get, in other words, if you had 3920, let me ask you, this 70 megahertz, what does it correspond to at RF? Assuming we're on the right up converter frequency, of course. What's this 70 megahertz going to correlate to? Right, center frequency. So this center frequency here is 3920. You know, if you're on this transponder, 3920 is your center. So if your modem is at 70 megahertz, what's coming out of your transmitter is going to be this plus 2225. Or coming back to yourself, you're going to see 3920. Now, let's say that we want a carrier of, we'll say 75 megahertz. Okay, we're going to put up a new carrier at one of our sites, and we want the IF frequency to be 75 megahertz. So what's the RF going to equal? What's my RF going to equal? Somebody besides Mark. Not that I don't want you to answer questions. I appreciate you being here. Most of this class, by the way, Mark doesn't need. He's here to help bring out questions. He's helped. Okay, there's things I'm not going to think about. He will. And Steve, he likes to catch me in mistakes. He's done that numerous times. Anybody got an idea? Okay, the center frequency 3920 correlates to 70 megahertz, so 75 megahertz is 5 megahertz above center at IF, right? So doesn't it correlate then that our RF is going to be 5 megahertz above center? That makes sense? So it's going to be 3925. Let's try it a different way. Let's say we want an IF frequency of 60 megahertz. Once again, remember 70 megahertz is center. That correlates with your center frequency of 3920. So if we want an IF of 60, 3910 is exactly right. Because this is 10 below.
3915.
No.
60 megahertz is 10 megahertz below center.
Yeah, so.
So your RF then would be 10 megahertz below your center. Okay? You with me, Gibby?
No, once, you're gonna have two different RFs going up on that.
No,
40
these are different examples. We only got one going up. Go ahead, Mark.
You can have several frequencies going up, several circuits going up, or frequencies, whichever way you want to state it, going up on that one transponder. Like he stated before, you could have anywhere from 100, 150 circuits up there, all at a different IF frequency.
So right now, he's going up on a transponder, and it's a 40 megahertz channel, right?
That's what it's slotted for.
That's the width of it, that's not the frequency of it, correct?
Right. In other words, this thing here, the center's at 3920, so therefore, what is my lower and upper limits? What's this going to be?
I may be wrong, if I'm interpreting you wrong,
20
Gibby, tell me.
20
I think he's talking about the 70 won't even fit in the 40, okay? In other words, he's looking at the frequency of the 70 megahertz frequency, and comparing it to your 40 megahertz wide there.
Okay.
You follow what I'm saying? Is that what you were looking at?
No, I'm just trying to distinguish how he gets the 75 megahertz and the 60 megahertz, or the 70 megahertz. Yeah.
Okay.
Why would you use one or the other? Is do the higher, like a 56 kilobit and a 19 kilobit, or?
Okay, I think I'm with you here. Let's say at, Fort McPherson, you've been to that site. Let's say we're going to put another, or let's just take your carrier. Let's just say that your carrier is at 70 megahertz. Not talking about bandwidth, we're talking about the frequency. In other words, you've got a carrier that looks something like that, and it's a 56 kilobit carrier, right? And you know how that corresponds to an occupied bandwidth. You're familiar with the formulas on how to do that. So this thing is so wide, depending on the coding rate and the data rate, it's so wide. But if you were to go CW, as you've seen many times, I'm sure, you used to go CW like that, then your carrier has a certain frequency. And let's just say, for instance, right now it's 70 megahertz. Okay?
Out of the modem.
Out of the modem. Out of your modulator, you've got a CW, and if you was to measure the frequency, it said 70 megahertz.
Right.
Now, you already know we're getting ahead of ourselves. If you modulate that, you're not going to be able to read the frequency. Since I jumped ahead of myself, why can't you read the frequency when it's modulated?
Because you got so many different frequencies inside that frequency.
Yeah? Put another way, that's a true statement. In other words, this is phase modulation, which is quite similar to frequency modulation. So the frequency is changing all the time. So the counter continues to count different frequencies. It won't lock on. Okay, so when you go CW, then your free counter will actually read 70 megahertz out of that modulator if you go CW. So you got a carrier here. We're assuming for right now at 70 megahertz, that's the frequency slot that it's at. It's a 56 kilobit, so when modulated, it looks like that. Now, if we uplink that through your converters, then the RF frequency out of your up converter is going to be 3920. Your up converter is going to be, you're going to select the frequency. You've got a crystal in there depending on what kind you've got. I don't remember now. But your out converter, now I'm really getting ahead of myself, your out converter is going to determine that its center output frequency is 3920. Now again, your out converter is 40 megahertz wide, so you're going to have a pedestal 40 megahertz wide coming out of your out converter. Approximately. It's going to be a little more. And if you've got an IF going in there at 70 megahertz, it's going to come out at 3920. because that's the main, one of the main purposes of an upconverter is to translate your IF frequency up to an RF frequency.
I think that's where he was losing. In fact, you're actually changing frequencies. You've got 70 megahertz coming out here, but it actually, when it gets the bird, it's gonna be at 39.
Plus
10,
2225,
whatever.
yeah.
Yeah, 60.
So you see that now? Your 70 megahertz goes into your upconverter, and it ups that frequency to 3920. If you put in 70 megahertz, it gives you 3920. I'm sorry, it gives you 20. Somebody want to add that up for me? It's going to give you 60 something. We don't have a calculator in the whole class.
6145. Look at your
6140.
top frequency. Yeah. Yeah, 6145.
Oh, yeah, on the other sheet.
Yeah, 6145.
Thanks, Mark. 6145.
But
So-
now if you leave that 70 megahertz signal there,
No,
then can't you, or the 70 megahertz signal, then can't you put another one at
Absolutely.
60 megahertz and it would
Right.
it move over to the other mark or?
okay, let's do that. Let's put in 60 megahertz now. We're going to leave this one in here.
Yeah.
We put in 60 megahertz, and that's 10 megahertz below center.
Right.
So now your upconverter is still going to multiply by the same amount. The thing is, we're giving it something 10 megahertz lower, so its output's going to be 10 megahertz lower. So now we got another carrier coming out here at 6135. Okay?
6130.
Not if my center was 6145. I'm taking somebody's word.
Okay, I got you, yeah.
Okay?
Yeah.
There should be 2225 between these two numbers right here.
All right.
Now, let's add a third carrier. Let's say we want to put something in there that's at 80 megahertz. Okay? We're going to put 3 carriers out of this side. Now we've got one at 80 megahertz. So it's 10 megahertz above center, which is 70. So it's going to be 10 megahertz above. What is it, Gibby?
6155.
Right. Okay, now, that was the simple part.
But the bandwidth determines whether or not you can use, if you could go from a 60 to a 70.
The bandwidth of your circuits,
Of your
yes,
circuit.
right.
I mean, if it was a wider circuit, you'd have to go to a lower.
Oh, okay, I think I see what you're saying. Let's try an example here. Let's forget these here. I think I understand your question. You tell me if this is what you're getting at. We're back to one carrier at 70 megahertz, okay? Now let's say we want to add another carrier, and it's going to be 71 megahertz, okay? 71 megahertz. But the thing is, that carrier, if it was a 56 kilobit, you'd be all right. But let's say we want to add a 2.048 megabit.
It's not right.
So well, first of all, if it's CW at 71 megahertz, then it's going to be right here at 6146. Agreed? But the thing is, if it's 2 megabits wide, it's going to get clear over here into this one, isn't it, when you modulate it? So that won't work. And that's what the guys at headquarters in engineering, they keep track of all them goodies. And that's why when you transition stuff to another satellite, it's a real bag of worms. Those guys got I'm sure they got computers help them do all that. Now,
It always goes perfect.
right.
Because that's the only way it will work, right?
Well, it works on paper. Well, I better be quiet. If the engineers ever get a hold of this tape, I'll be in big trouble. But if we had, since this is on tape, if we had to walk in their shoes for a couple miles, it wouldn't be near as easy as we think it is. Now, let's talk about, now they went don't ask me why, I don't really know, but now they've jumped up and we've got transponders that are 80 megahertz wide, and that one's 3980. Now this baby here is 80 megs wide and it's 3980.
Question,
Yes, sir.
did they go to those for video purposes?
No, I don't think so, because for years we've had video on the old Westar system, which is only 40 megahertz wide. You know, and we have a lot of earth stations that are TDMA, and they're 40 meg wide,
Yeah,
right?
they pick up the whole transponder.
They actually are 60 megs wide. And don't ask me to explain that one. I have some ideas, theories. How can they take a 60 megabit TDMA and put it on a 40 megahertz transponder? That's always kind of boggled my mind. I've never really worked on one of the big earth stations where they have TDMA. My guess is, number one, just because it's 60 megabits, we don't really know what the occupied bandwidth is. I don't know how to calculate that for TDMA.
I used to when I get my formula.
So it could very well be that the occupied bandwidth is something less, and again, I'm speculating here. Another thing, too, is that I've heard rumors that they actually bleed over into the guard band on both sides. I've heard that from good sources, but I can't say that on tape. Okay? So they actually put 60 megabits, which is, and video uses 40 megahertz. So we got 3980. Now, remember, your center is 70 megahertz. Once again, you know, that's the center of our IF equipment. The center of this transponder is 3980. And again, this is plus or minus 18. So let's jump up 18, and that gives, jump up 18, and what's that going to give us? 88, right? So we want to put up a carrier at 88 megahertz, and that's as high as we can go. IF, we can't go any higher than that. Equipment won't work. As you'll find out, some synthesizers don't work there either. Something to consider. If you change frequencies and it doesn't work, and you went way down to the bottom around 52, some synthesizers don't work there. They're supposed to, I mean, but I've seen that happen many times where they'll work at some of your frequencies up toward the middle, but they don't work down in the low. So anyhow, we want to put out a carrier that's 88 megahertz. That's as high as we can go. So what's that going to be up here? Oh, these things are, I guess I got to keep covering them up. Say what?
39.98 like you did.
That's right.
It's 39.95 sounds better if you're buying something instead of 39.98.
Everybody agree? Well, I put that in the wrong place, though. Now we're going to have a carrier over here at 39.98. Now, why did I put it there? Remember, what is this right here?